We'd like to examine the growth of a tree. Now, a small sapling has a weak stem, but as it grows into a tree, it's got to have some structural material to help support all the massive branches above it. We're going to ask what fraction of that trunk is still living tissue. Let us look at a portion of that trunk. So, to a first approximation, this can be considered to be a cylinder. In the tree trunk, there's a thin shell of material that's still living, often referred to as the phloem, and the interior of that tree trunk is no longer alive. It's basically wood. It supports the structure. The first question we'd like to ask about this problem is, what fraction of the tree trunk consists of living tissue? Now, to answer that question, let us first observe that the volume of the trunk in its entirety, since we've approximated it as a cylinder, is going to be simply pi h times capital R squared, where capital R is the radius of the trunk. Let's also note that the volume of the wood will be pi times the height of the cylinder times R minus D, where D is the thickness of that living tissue, squared. Let's write down actually the ratio of the volume of the tissue that's alive to the entire volume of the trunk as a whole. And so we're going to get the following. The living tissue, first of all, is the difference of these two quantities. Now we can put the pi and the h outside, and we can write inside here the trunk radius squared minus the radius of the wooden part of the trunk squared. And now let's divide by the volume of the trunk as a whole to get a fraction. Now we can observe immediately that pi h cancels from top and bottom, and so the fraction of the tissue that's still alive will be now dividing through by r squared. It will be 1 minus r minus d squared divided by r squared.